Good day, everybody, and today it is Geogebra 7 lecture, and we will continue our discussion on sequences, and we will take a much deeper look into the sequence instruction, and we will discuss also how in a different way also sequence can be created. So let us straight away go to the working table uh, here, and we will start our GeoGebra, as you know. And you recall that we created sequence in this fashion, that is sequence within first bracket sequence. You write any function to the power say k, 2 to the power k, comma, to the power k, comma, comma k, comma 1, comma say 5. If you do like that, it creates a sequence. Recall that this is the function, and in default the increment is taken as 1, but nonetheless you can also specify the sequence, as I often do, to avoid any confusion in my mind. Therefore, this is the how these 5 numbers are created. And this particular way of creating a sequence or a list, this creates in return a list, and it is given a name. Okay, and this list is somewhat a disciplined list, in the sense that each element follows certain rule, 2 to the power k, depending upon its position. And how to get access to any of the elements of this sequence? What you do, you simply write element, name of the list, which is L1, within the brace L1, comma say 3, and it faithfully gives you the number 8 here. Now, if you create a sequence in this fashion, whatever you have got, some numbers, and it is not going to produce any output in the in your graph paper, and also you can understand there is no button created here, means that it is not going to produce any output on the graph paper. So this is how element is created. Okay. Now another alternative way of so any element of this sequence could be accessed by writing down this number. For example, if you write 4, it will give you 16, fourth element of this sequence. Good. Now there is another way of creating a sequence excuse me, and that is this one. Suppose within 2 braces, if you create a sequence, you write some numbers 2, comma, or I will say I will write a sequence of these things. 1, comma 2 is the coordinate of a point. This is one element, mind you, comma 3, comma 4, this is the another element, comma say 5, comma 6. So a sequence is created. The elements are total number 3, and each one is a point. Okay, and in return, this also creates a list. Here, as you can see, L2 is created. Now you note that here appears a button here. It means that GeoGebra knows that each element of this list L2 is a coordinate of some points, and it will show these points here. If you click this, you see all the 3 points are shown. Okay, you can easily verify. Therefore, this element is this sequence is created in this simple language. You don't have to write sequence. Sequence writing is a must. If some function you use whose variable you want to change, a ordered sequence you want to create, you do like this. Mind you, whenever a list is created, either following the sequence command or by simply writing down the elements within 2 curly braces, end results are lists, and the element of each list of course can be found out in the same way. For example, here if you are interested to pick out this element, second element of this list L2, you simply write element and within the brace name of the list L2, comma 2. If you write, it will give you 3, 4. You know, 3, 4 is this one. So after the list is created, either by following this rule or by following this one, it does not matter, element can be accessed. Okay, now I will tell you something more. So this is there. This we can delete. It is not so important. You have understood this, and let me suppress this also. So this is the 2 ways you can create a sequence, and the sequence elements, how they can be accessed. Now, another interesting way of one can create a sequence of various functions. For example, I want to create a sequence of x comma x square comma sin x. So it is expected that it will create a list of 3 functions, x, x square and sin x. The element of L3, each element represents a function. Okay, this thing you will not be able to do by using sequence. That you must, that is what I want to tell you. Okay, is L3 is going to produce an output? Yes, because there appears this symbol and it is deselected. The moment you select it, you see it shows all the 3 functions. The first function x, second function is x square, and the third function is sin x. And of course you can choose any one of these elements in the same way as I have told you, like this. For example, cancel this, I did something wrong. So this is the element, and you simply say that the second element you want to create. What you have to do? Name of the list, that is L3, comma 2, and only this curve, parabolic curve, is picked up and displayed here. Is that point clear? Therefore, this is how you can choose. Of course, another way, if I tell you, then it will complete whatever I wanted to communicate to you, that particular thing about sequence, is that the element of any sequence created either by these or by curly braces, it does not matter, element of a particular list can be accessed as well simply by writing down the name of the list, for example L1. L1, recall, is this, it is showing all, but you simply write say fourth element, it gives you 16. So this is another shorter way of accessing a particular element, say fourth element. Similarly, in contrast with this element, name of the list, for example, I will repeat the same thing. For example, I could also access that point as element. Let me do that so that you will appreciate which one is more advantageous out of these two instructions to access a particular element in a particular list. For example, you could also get the same result, I suppose, of L1, name of the list, comma 4. It also gives 16. Got the point. Now, which one to be used to create a list will be totally your choice, and you do that, and perhaps you'd like to access that particular element, and you can access either in this way, element, name of the list, comma the element number, and or in a much more shorter way, name of the list, in the braces, first brackets, the number of the element. Same thing you will get. And as you can see, you have accessed the element of a L1 element you have accessed, and L1 is nothing but, L1 is nothing but this, and this is not going to produce any output since they are simple numbers, and no circles here have been produced. These buttons have not been produced. Okay, with this background, we will do something that is now what we are going to do. Really, where should I use the sequence commands? We will see right now that these sequence commands help us to do lot of things in one stroke. Okay, without talking, let us see what I mean to say by this. For example, I clear all the things here. Okay, don't say, it is a clean board now, and keep your origin at the middle. And here, suppose I do like this. For example, I say sequence, please follow me carefully, sequence. Of course, there is a help forthcoming here. You can choose that, but I am not doing this. I will straight away go here, and I will say that I'll write the coordinate of a point, say -4, comma, say I will say k. Now as you can understand, this is the function. Okay, I am using sequence command, so the function is this. Then what I have to write, comma, the starting value of k. I have to write starting value of k is anything shall I write? Say 0. Let us write something. Okay, comma 0, comma, say final value is 5, and comma 1. If you want to see the full command, you can expand it a bit here, and what output it has given. See, this is the command, -4k, this is the function of k, and it is a point, and 0, final value is 5. The y coordinate I am changing from this to this. Got the point? I could also slightly, I will edit it here. So I will write say -5 to +5 to have a symmetry here. Okay, so many points are created in one stroke, and as I told you, see, I could create these points one by one, taking a lot of time. But I can now create all these points like this. That's all. So I use the sequence comments, and any element I can find out. Let us further go with this. Now suppose I say that what I am going to do is this is the origin. It's a point whose coordinate is 0, 0. I would like to make several line segments joining this point and all other points. For example, I will join this point, next point, this point, this point, this one, this one, this one, this one, this one. Okay. So I want to draw a number of line segments joining one point is fixed, 0, 0, with other points in the elements. Now let us see whether sequence comment help us to do that very quickly. Let us see. So the point is sequence. What I want to do? I want to do a segment. You recall, segment comment means line segment. For example, this will be a line segment if we join this and origin. Okay. So sequence, then segment. Now, when you want to get a segment, what should be inside these two braces? What should be there inside? The coordinate of 2 points. Then you get a line segment. Recall our earlier lectures that we have explained to you. So here, 2 coordinates of those 2 points between which you want the line segment to be present, I have to write the coordinates of those 2 points. So one point is 0, 0. This is the one point. And what will be the second point? The coordinate of the second point will be the coordinate, x coordinate of all the points is -4. So -4, -4. Then you say, comma k. So your segment is this one, and this whole thing is function of k. Then what I have to write is how k varies. K varies from, say, -5, k comma -5, final value +5, comma 1. Put a return. And you see this desired thing, that is with the origin, I have been able to join all the points here just by writing a simple instruction, and you should be logically clear. I once again explain this step so that you can try something different from this, but the argument you should be absolutely clear. Here is a sequence. These are the two braces between which there will be a function of k. What is that function? Function is a segment, and what a segment is, line segment between two coordinates. So 0, 0, that is my fixed point, and then I want to join this point whose x coordinate is fixed, -4, and its y coordinate I will be changing, -4k. And now I must specify how k is varying. So k will change from -5 to 5 with an increment of 1, and this thing is done. Got the point? So you will be getting this result so quickly. Now, if you have understood this one very clearly, then we can do more experimentation with this. For example, I will just block this. What I will do, I will create a slider. Just see. For example, I create a slider, say n. Okay, and it is a slider. Suppose I say I will change it to say slider, its minimum value is -10. I will change it. Maximum value is +10, and 10 with an increment of 1, suppose, and the initial value set is 10. Now what I am going to do is I will be creating first these points, for example. So for this now I will be doing like this. See, I no point in retyping this thing. You simply copy this, duplicate the input, and duplicate the input is this one, but only thing is here this variation of k I will do, it is the value, and I will change a bit this n value, okay, to avoid any confusion. First I come back here, setting, and suppose n I vary from what? My god, no, I have to change the setting of the slider. I go there, go to the setting, and slider, this value I will make 0 to 10, positive value. You will understand why I am doing like that. Anyway, it is like this. So here what I will do, I will edit this k value -n, -n, comma, the final value +n, comma, here with an increment of 1. I do like that. Okay. If you put a return, it only creates 3 points because the initial value of n has been set to 1, and it will do like this. Okay. Clear? Similarly, I will so you can easily see, as you increase the value of n, more points will be created depending upon the present value of n. It is the extension of this particular thing. Similarly, the line segments, what I will do, you copy this comment, duplicate input, and it comes here. But here only thing you do, -4k, k comma, here you write -n, and here you write +n, comma 1, and your segments are ready, is not? And it is there. And if you vary n, you can see it has done all the things, and if you allowed it to play, it will go on doing like this. Clear? You can bring it down a bit. So it will go up to +10 and -10, and has been creating this so-called pattern or locus of the line segments as you vary the n. So I think you have understood the point. And I will stop here today, and we will continue our discussion next time with much more exciting things. But recall that, to summarize, what I want to tell is that you can create sequence in various ways, in at least 2 ways. When you want to create a sequence within braces, you can create any arbitrary sequence, and whether it will produce any output or not, look at this site. And also, you know, if it is simple numbers, it cannot create any output. But anything which GeoGebra understands can be created in the algebra, in the graph paper, it will create. And you can select it and get it. Next question is, once you do sequencing, end result is it produces a list. Once the list is produced, it doesn't matter how the list has been produced, whether by using this command or by a sequence command within curly braces, it does not really matter. You can access any element, and also, of course, accessing elements can be done in 2 ways. One is simply writing the name of the list, and in the first brackets, name of the elements, number of the elements, okay, what you are interested in. Similarly, a sequence could be a collection of functions, and that is also very useful, and you can pick up any function you like out of so many, perhaps in a sequence list. So thank you so much for being with me, and hope you have enjoyed this, and we'll continue our discussion on sequencing to do much more exciting thing in the next lecture 8.